First activity that you're going to do in IXL is you're going to take two equations, you're going to graph them, and you're going to decide, once you graph them, do they have no solution, one solution, or infinitely many solutions? Now, once you see the graph, you can look at your notes and you can see, okay, if the graph looks like this, where the two lines are parallel, they'll never meet, that's no solution. If they're sitting on top of each other, that's infinite solutions. And if they cross each other like this and they just meet at one point, that's one solution. Now, remember, we can also use our notes to kind of observe the equations even before we graph them. So for example, the first two equations are in slope-intercept form, and what we're going to observe is they look like this. They have the same slope and they have different y-intercepts, so we kind of know even before we start that our lines are going to be parallel. Let's take a look. I notice that these two lines both have the same slope. They both have a slope of -1, right? And they have different y-intercepts. So when I graph these lines, right, like this line, we'll start at 4, and then this slope, this is a -1 slope, so that's -1 over 1, so I'm going to go down 1, right 1. That's that first equation. And then this second equation, I'm going to start, and notice I just clicked this orange button. I'm going to start at +2, and I have that same slope, so I'm still going to go down 1, right 1, which is going to create these parallel lines. Now, these lines will never intersect, so these lines aren't going to have, this system doesn't have a solution because the lines never intersect. So I'll click no solution, and I'll go on to the next problem. Let's try a couple more. These equations look similar, but there's an important difference, which is these slopes actually are not the same. This slope is +1. Let's graph this line, right? This is a y-intercept of 5, and this slope is 1 over 1. I'm going to make it into a fraction, right? So I'm going to go up 1, right 1. Whereas this slope is actually -1, right? So here, I'm going to start at my y-intercept of -5, and I'm going to go down 1, left 1. Now, these lines intersect at one point. That means they have one solution. And I could have told that just by looking at these equations because they have different slopes. So once they have different slopes, I kind of know the answer is going to be one solution because they're not going to be parallel and they're not going to be sitting on top of each other. Okay, let's try a couple more. Here, I'm going to start at 6. I'm going to take my slope is -1. That's down 1, right 1. I already know this is going to be one solution because my slopes are different, right? So here is this one. This is, again, one solution. Okay, now, what do you notice about these equations? These equations are the same, right? So when I graph this, and I start at a y-intercept of -1, and then my rise is 2, and my run is 5, and then I do the same thing again. I start at -1, and my rise is 2, and my run is 5. I end up with the same line. These lines are just sitting on top of each other. That has infinitely many solutions, okay? Now, what you're going to get to when you get up to a little bit of a higher level is you're going to get up to equations like this. These are in standard form. Now, you have two options when you graph in standard form, right? One is for you to use the intercepts and graph the lines, right? For you to plug in 0 for x and get the y-intercept, and plug in 0 for y and get the x-intercept. The other option is for you to rearrange these into slope-intercept form. So for example, if I were to take this first equation and rearrange it into slope-intercept form, I would first subtract 1x from both sides, and I know this is not the neatest, so sorry. I would get, right, remember I'm trying to make this look like y equals mx plus b, so that would look like this. I would realize, oh, this y is being multiplied by -1. I would divide by -1 all the way through so that I can get my equation in slope-intercept form, because then it's easy for me to graph in slope-intercept form. I have a lot of practice doing that. This becomes 1x, right? -1 divided by -1, this is 1x, you could write it, minus 6. Okay, so that's my first equation, and I'm going to go ahead and change the second equation into slope-intercept form as well. And the process is going to look pretty similar because the second equation doesn't actually look too different, right? It's just that it's got this 9 here. But look, I'm going to save some time. I'm still going to subtract this x from both sides, and I'm going to still have, right, something like this, -y, and I'm just using my work from above to save myself some time and writing with this mouse. Okay, so again, I'm going to divide by -1 all the way through, and my other equation is going to be this, right? When I divide by -1, divide by -1, divide by -1, divide by -1. Notice what I get. So now, right, and this is an invisible 1 right here. So if you look at my two equations that you can now see in slope-intercept form, we see they actually have the same slope, which is 1, and they have different y-intercepts. So I know that these are going to be parallel lines because I see that they have the same slope and different y-intercepts. So I'm going to go ahead and graph these. Now this is something you would do on paper. So I have 1x minus 6 and 1x minus 9. So this is 1x minus 6, and this is 1x minus 9. I can see that they're parallel, and that means I have no solution. Okay, so that is what this looks like. And you can see at the higher levels, you're going to end up with these equations in standard form. Right away, however you choose to graph these, you can see these are the same equation, and they are going to have infinitely many solutions because when we graph them, they're going to sit on top of each other.